Okay, so this first question on out of chapter 7 for the WebAssign assignment, always want to run condition checks. Okay, if you look in the book, you'll see that this is in the section that says population standard deviation is known. I would know that because here, let me get a pointer going. As I read through, we're known that the number of hours that college students sleep. Let's see, blah blah blah. Let's see. We know for all people, the average is 7 hours with a standard deviation of 1.15. So that's the population for quote unquote all people. So then we go out. So that tells me that's a population standard deviation. Now, we don't know anything about the shape of the parent population, do we? But we do know that we have a sample size bigger than 50. So the central limit theorem will work. Okay. If we had a very small sample size, we'd have to know that the parent population was normal in order for this work. So those are those requirements that you can look at, those condition checks. This will help you make sure you're doing the right test or the right technique. So this is using the Z distribution because I know the population standard deviation. So they went out and they did the sample, and as far as we know, the point estimate, that's what we're guessing the average is 6.3. So that's my point estimate. See, that's coming from the sample. Is that different from the average of 7? Yes. What we got to do now is we're going to see if it's far enough away to 7 from 7 to say that something's going on. Either 7's wrong for this group of college students, or they aren't, their true mean isn't 7.0 hours, or it's just a bad sample. That's the other thing that can happen. More on that next week when we do chapter 8. So the point estimate is 6.3. That came from the sample. Now, the critical value of Z for a 95% confidence interval, because this is a Z distribution, we can look in our normal curve table, right, from the book. This is the only reason why this table is useful. Is this, I mean, besides finding areas, let's see, where is the normal curve? Z, here we go. These. So if you look at the bottom, it's on either page. Do you see this common? Maybe I can zoom in a little bit here. Sometimes Zoom won't let me zoom. Sometimes Zoom won't let me zoom in. Oh, yes, it will this time. Okay, so you see that these are the critical values for 90, 95, 99. So we don't have to do anything fancy. So the critical value of Z for a 95% confidence interval is 1.96. Standard deviation is what that is. So that's what that is. We don't want to do the negative, which is just the positive of it. So we'll add and subtract it. Now to get the margin of error, we're going to do this. We're going to say, so if you look in the book, it says we know that it's going to be X bar. The general form of a confidence interval is the sample mean plus or minus the margin of error. And to get the margin of error, we take the Z star. How many standard deviations around the mean do we want to travel? Times by the standard deviation for the sampling distribution. So you got to do that extra step like that we saw back before the exam in chapter 6, where we had to find the standard deviation for the sampling distribution. So for this problem, we know the critical value of Z is 1.96. So 1.96. And we know the standard deviation for the sample or for the population is 1.15. Notice that I use that funny little O with a line over it. I think it's a lowercase sigma, if I remember my Greek letters correctly. So we take that divided by the square root of the sample size. When we don't know the population standard deviation, we substitute S, the sample standard deviation, for that. And then, of course, we use the T distribution, but that's another thing. So let's see, what do we got? 50 college students. So if we calculate this, that'll be my margin of error. So on my calculator, I'm just going to grab my handheld calculator, not show this on the screen. I'm going to type in 1.96 times 1.15, right? Divided by the square root of 50. And I'm getting 0.31. Oh, I don't know. How many decimal places is WebAssign looking for? 3 decimal places. So I'm looking at 0.3. I'm getting on my calculator, I'm getting 0.31876, blah, blah, blah. So I'm going to go to 3 decimal places. So I would have to type in 0.319 in order to get that answer. Now to get the confidence interval, we know the margin of error, and we know that it's going to be the mean, sample mean up here, the sample mean plus or minus the margin of error. So to get the lower bound, we'll do 6.3 hours minus 0.319, and then we'll do 6.3 hours plus 0.319. So the margin of error, subtract the margin error from the sample mean, add the margin of error to the sample mean. Those are the two bounds. Now, yeah, are we confident? Are we confident the average college students get less than 7 hours of sleep? Well, this is the upper bound. 7 is more than. So what we're trying to see, right, is we're trying to see. Okay, here's the mean, 6.3, and the upper cutoff will be what? 6.619, and 7 hours falls outside that range. So yeah, because that 7 is outside our confidence interval, it's above. We are confident that the student, on average, the college students are getting less sleep than the normal 7 hours, and that's because the 7 is above the upper limit of the confidence interval. Okay. And then basic answer part D, you're 95% confident the average. I guess I got to think about what's going on here. Just let me reread it. Sorry about that. Let's see. Oh, less than 6.5. I guess why 6.5? Well, no, I'm not, because 6.5 is inside the confidence interval, right? Yeah. And then for part E, yeah, we aren't told. So I talked about that. I touched on that at the beginning. We aren't told about the parent population, but we've got a big sample size. Sample size is bigger than 30, so that means the central limit theorem holds. Okay, so because the sample size is bigger than 30 is the right answer. Okay, so that works. So the big thing, in closing, the thing you want to pay attention to with all of these, actually from here on out, you're going to make sure that the problems meet the conditions required for the tool. So here, because I knew the population standard deviation, I'm going to use the Z distribution. And that's because we got this nice little table. That's pretty easy to do. It's almost easier to do it by hand than go find a calculator. This calculator's out there, but honestly, you can go find one if you want, but I'm not going to show you how to do one because I think that is worth doing by hand. And then when we get done, let's find one that's not. So now this is about proportions, and yes, proportions use the Z distribution, but that Rossmann chance here, that Ross, do I have that open? I don't see where I have it open. That Rossmann chance applet, this is the one I linked to, said your new best friend. See, you select which one you want, and proportion, it'll do it all for you. Okay. If you got a mean where you don't know the population standard deviation, you want to do this. This uses the T distribution. Don't do this for the one I just did, who we knew the population, parent population. This calculator won't do that for you. This only works when you with the sample standard deviation. We know the sample standard deviation. And then next week when we do 2 weeks from now, when we do 2 samples, and this is so much easier than formulas. But more on that when we get there. Okay. So that's a good video, I guess. Let me stop this.